Hi, in this video, I'm going to do the 2017 O-Level Science Chemistry practical paper. So I'll begin with part A. It says, use a measuring cylinder to transfer 8 cubic centimeters of solution X into a small beaker. So I have solution X, and then I need to use a measuring cylinder and then transfer 8 cubic centimeters. So I'm going to do that. So when I transfer the solution from the bottle to the cylinder, I make sure that the tip does not touch. Okay, so the correct way to use the measuring cylinder is actually not to hold it in mid-air, but to leave it on the table. And then you get off your seat with the measuring cylinder flat on the table. You bend down, move your entire body until you can read the meniscus at eye level, and then you want 8 cubic centimeters. Okay, so you want 8 cubic centimeters, and then we put it into the beaker. This is the beaker, 8 cubic centimeters. Use a different measuring cylinder. So this is a different one, a clean one. Transfer 10 cubic centimeters of solution Y. I have now solution Y. I need 10 cubic centimeters, so same thing. I put the measuring cylinder on the table, and then I transfer 10 cubic centimeters of solution Y. Okay, so you read the meniscus at eye level. This is 10 cubic centimeters. Transfer it to the same small beaker. So here it is. So after we put the chemicals together, what we will always do is we will stir to mix well. Okay, so here we are. I use the glass rod. Stir to mix thoroughly. So here we have an observation, a color is exhibited, and then there's a certain texture of it. What we notice is now light cannot pass through the mixture. What we want to focus on is the color. So I would say this is green, and there's a little bit of specks of white that I see inside the mixture. So I will call this a green and white precipitate form. Okay, the colorless solution forms a green and white precipitate. I need to observe the contents of the beaker for about a minute. Okay, so we will have it here, and then we will wait for a minute and see what happens to the content of the beaker. So this is about a minute or so, and I noticed that the green still looks green, but what has happened is it looks a little bit darker green. Okay, the green color is a little bit darker than it was. So the observation that I will record now would be after 1 minute, the green precipitate turns darker green. Okay, So it's still green, but it's a darker green color. So that's the end of part A. The next box in part A, place 2 test tubes in a test tube rack. 2 test tubes in the test tube rack. Two test tubes in the test tube rack. Here they are. Add about 2 centimeters depth of sulfuric acid into one of the test tubes. This is sulfuric acid. I need 2 centimeters depth. So 1 centimeter is about something like this, about say the height of a pinky little finger. So 2 centimeters is there about. So I need 2 centimeters. So I suppose this is about 1 roughly, and then I would like 2 centimeters depth. So here we are, 2 centimeters sulfuric acid, and leave the other one empty. This is the empty one. Place the filter funnel with filter paper into the empty test tube. So we have a filter paper. This is how we fold the filter paper. First, you fold it into half. That means you fold it into a semicircle. Then you halve it again until you get a quarter, a quadrant. When you open the filter paper, you open with one piece on the one side and 3 pieces on the other side so that you get a cone. Okay, so this is the correct shape of the filter paper. Filter funnel, filter paper in the filter funnel, and then this will be put together with the empty test tube. Stir the mixture in the beaker and pour it into the filter funnel. So I will stir the mixture. You can use back the glass rod. Stir the mixture and then pour it into the filter funnel. So I'll pour it into the filter funnel. You can hold the paper down with a finger and then pour it. Filter it through. Initially, it is likely that a small amount of solid material will pass into the test tube. Once the filtrate is running clear, move the funnel into the test tube containing the acid. So I need to watch out for the clearness, the transparency of the filtrate. They say once it turns clear, that means at first it may be a bit cloudy like now. The filtrate is a bit cloudy, so I'm not ready to move. When it turns clear, the filtrate, the droplets coming down from the filter funnel, when that turns clear, I will move this entire funnel into the other test tube, and the residue left behind is salt Z. And then as we filter, we want to pay attention to the residue and the filtrate. So the filtrate at first is cloudy, it's a bit greenish. There is actually some color that is appearing at the residue, which I would want to record. So this is how the residue looks like. Okay, so there's a bit of, it is the green residue that we expect. And then there's a bit of yellow-brown color appearing. Okay, so you can record down that there is a bit of a yellow-brown color solid form at the filter paper, the residue. While we are waiting for this to filter, we will continue with part B. So I shall let this filter and go to B part 1. Add 1 centimeter depth of solution X into a clean test tube. So I get a clean test tube, 1 centimeter depth. Solution X, 1 centimeter. So 1 centimeter about like this. So you can always use your little finger to estimate 1 centimeter depth. To this test tube, add about 1 centimeter depth of sulfuric acid. So I still have the sulfuric acid here. I need 1 centimeter. So 1 centimeter. Oh. So as soon as I add some of the sulfuric acid, I notice that there is bubbles or effervescence, and that I need to write down. So my observation is bubbles seen, or effervescence seen. Okay, I have not yet added fully the 1 centimeters, and then the bubbles is already gone. So what I want to do now is I will add a bit more of the acid because I need to generate more bubbles because I need to test for the identity of this gas. So now the question is, what test should I do? So I realized that I have put together an acid with an unknown X. So it's helpful that I know that this is an acid because I know that acids can react with two different kinds of chemicals to give effervescence. One of them, acid can react with metal, which can give hydrogen gas, or acid can react with carbonate to give carbon dioxide gas. Now I want to turn my attention to the unknown that the acid is reacting with. So this X looks like this. It's a colorless solution. So given the appearance of X, I do not think that X could be a metal, that X could be metallic, because metals don't look like this. Metals are always gray solids, or are always solids, gray in color, shiny gray, silvery. Metals are never solutions, right? Elemental metals are never solutions. They're always solids. So X is not a metal. Hence, I do not test for the presence of hydrogen gas. I now strongly suspect that the effervescence that I saw contains carbon dioxide gas. So then I will put this aside. I will continue with this, but now I need to get ready the lime water to test for the carbon dioxide gas that I suspect. So lime water, we take the smaller test tube, the shorter one, put some lime water inside. How much is good? About 2 cubic centimeters is good. So this is lime water to test for the presence of carbon dioxide. We add about something like this, about 1 or 2 maximum, 2 cubic centimeters of lime water. You will need a delivery tube. Put the delivery tube to sit in the test tube of lime water. This is how the lime water test tube always looks like. This is the setup for lime water test. And then now I'm going to have to connect, but I will not connect now because there's no more effervescence. The reaction had long ended. I'm going to add more reagents and generate more of the gas and test if that gas is carbon dioxide. So I'm going to now add a bit more of the sulfuric acid and be quick to connect the two tubes. Okay, so I try to mix the chemicals. There are some more effervescence, and I see if it will form a white precipitate in the lime water. So I keep shaking the reacting mixtures, reacting chemicals, the acid, sulfuric acid, and X. And then now I have it. Effervescence seen, and the gas forms a white precipitate in lime water. Okay, so that's the answer for B part 1. Effervescence seen, the gas forms a white precipitate in lime water. So I now go on to the part 2. Add about 1 cm depth of solution Y into a boiling tube. Boiling tube is the bigger one, bigger than the test tube. The boiling tube, add 1 cm depth of Y. This is unknown Y. I add 1 cm depth. Okay, so it's about 1 cm depth. Add aqueous sodium hydroxide slowly with shaking until no further change is seen. Sodium hydroxide is this. So I need to add some and then check whether there is precipitate form. So this is now the test for cations. So I add some, a few drops, and then I shake to mix. And then I see now this, the observation is a green precipitate is formed. Green precipitate is formed. Then the instruction says until no further change. So I'm going to add some more. Then I realize the green precipitate stays. It is still cloudy, light cannot pass through, I still cannot see through it. So I know that there is still precipitate. So the answer for the B part 2 is dirty green PPT form, insoluble in excess sodium hydroxide. So I've already added the further 2 centimeters depth of aqueous sodium hydroxide, and then it says, and gently heat the mixture until it is almost boiling. So what the instruction is telling me to do is add sodium hydroxide, which I have, and then heat it. these two steps, when put together like this, adding sodium hydroxide and heat, is the test for ammonium ion. It's the test for ammonium ion, which is the positive test result is the evolution, the production of ammonia gas. And the test for ammonia gas is that the gas will turn damp red litmus paper blue. So before I turn on the Bunsen burner, I want to get ready the red litmus paper. So you take a piece of the litmus paper, red color, and then I would want to dampen it first. So we will dampen the litmus paper using deionized water. Okay, so never tap water, deionized or distilled water. And then you dampen it. You can do it actually right at the table. Dampen the piece of the litmus paper, which litmus paper must always be dampened. So I'm going to heat it. So now I'm going to have to turn on the Bunsen burner. So the steps to turn on the Bunsen burner includes to the gas tap, lift it up, turn it on. The air hole, in this case, must be slightly partially open, something like this. We use the lighter, and then we light it. Okay, because we are going to heat the solution, I would close the air hole a little bit. Okay, I will close the air hole a little bit to get a weak flame, orange flame, which is a safety flame, suitable for heating the solutions like what we are doing today. We hold the boiling tube using this thing, the test tube holder. The test tube holder, we will put it at the neck of the test tube, where the words are. Okay, so we'll put it here. And I need to put on my goggles. Okay, so I'm going to do one thing at a time. I'm going to heat it gently as the instruction says. And then, knowing that this is the test for the ammonium ion, I'm going to test for the presence of the ammonia gas using the damp red litmus paper. So let me heat it a little bit more. Okay, so I will put the litmus paper at the mouth of the boiling tube. And then I see that the gas turns the damp red litmus paper blue. Okay. The gas turns the damp red litmus paper blue. So the answers for the B part 2 would be, at first, dirty green, PPT form, insoluble in excess. Upon heating, there were effervescence and bubbles. And then the gas turned damp red litmus paper blue. Okay, at this juncture, I am ready to go back to the filtration that I did. The filtrate is now running clear. So the filtrate is now running clear. So I'm going to shift the filter funnel into the other test tube. And then allow the mixture to continue filtering. So now B part 2 has finished. While you are waiting for the contents of the tube to settle, continue with B part 3 and part C. So now B part 3, add about 1 cm depth of solution Y into a clean test tube. So another clean test tube, solution Y, add about 1 cm depth. Okay, there we go, 1 cm, about there. This is a bit more. Okay, I think I'll throw some away. 1 cm, thereabout. Add aqueous ammonia slowly. Aqueous ammonia, add slowly. Okay, a few drops. Stop, mix, and then you observe a PPT. Light cannot pass through. This is a PPT. The color is, again, dirty green. The instruction says, with shaking, until no further change is seen. So we add a bit more. And then we realize that it is still cloudy, still chalky. The PPT doesn't go away. So B part 3 answer, the dirty green PPT is formed, insoluble in excess. Part 3, dirty green PPT form, insoluble in excess. Now part C, using a spatula, carefully transfer about half of the moist residue Z from the filter paper into a clean test tube. So I'm now going to take the residue from the filter paper. It says about half. I'll use the smaller end of the spatula so that it can fit into the test tube more easily. So it's still a bit moist, but that's fine. About half. Okay, so I think that's about it. Half. Gently tap the test tube on the bench to force the precipitate to the bottom of the test tube. So my tube now looks like this. Some of the precipitate has come down. Tilt the test tube and carefully add about 2 cm depth of sulfuric acid down the inside of the tube. You should try to avoid disturbing the precipitate too much. Do not shake the test tube. So I'm going to try that. Sulfuric acid. I want to make sure that when I transfer, right, the dropper's tip doesn't touch any of the green precipitate. So I'm going to add some down the inside of the test tube. Let's do this. Okay, so the moment I add it in, I notice there is effervescence. So my answer for part C, it will begin with effervescence seen, which means I must test for the gas again. So again, it brings me back to the point where I realize I'm adding acid to another unknown. Now is dirty green looking. And again, I figure this green thing can't be a metal. It can't be a piece of metal, right? So I deduce that this is, again, unlikely to be hydrogen gas being involved, more likely the carbon dioxide gas that's involved. And so I now need to test and confirm if it were carbon dioxide. So I'm going to leave this to stand. I'm not yet done with this part. I'm going to get ready the lime water again and then test. So this was the tube I used just now. I'm going to wash this and use it again. So to this tube, now, I will add in some more lime water, and then I'll add about this volume, about 1 to 2 cubic centimeters, no more than this. This is good. Put the delivery tube into the lime water test tube. This is the lime water test tube setup. I'm going to connect and test for the gas. So like just now, I'm going to again generate more of the bubbles to see if, so that it can be passed through the lime water, and then I hope to test for the presence of a white precipitate. So let me try this. Okay, I'm going to have to shake a little bit, but there seems to be enough of the effervescence that's coming out. Okay, and then I see that again the gas forms a white precipitate in the lime water. Okay, so with this I disconnect. I leave the delivery tube still in the test tube of lime water, and then I need to observe the test tube for 1 minute, and then later on I will shake the test tube. Okay, so let it settle down. So part C answer will begin with effervescence form. The gas forms a white precipitate in lime water. When I initially added the sulfuric acid to the clean test tube, when I initially added the sulfuric acid to the residue, there was a color of the solution that was formed, and the color was a brown or yellow solution. Okay, so now I observe the test tube for a while, get green solution, green PPT. I shake the test tube until no further changes are seen. Okay, I'm going to add a bit more of the sulfuric acid, 2 centimeters depth. Now I shake, and then I get this, which I need to record as an observation. So 1 cubic centimeters of, the precipitate, right? And then 2 cubic centimeters of the sulfuric acid. So I get this as an observation. What I will write is, after 1 minute, upon shaking, the green precipitate dissolved completely, and a yellow or brown solution is formed. So that's the last answer for part C. The next part, last part, transfer about 1 centimeters depth of this mixture into a clean test tube. So I need to change it to a clean test tube. Transfer 1 centimeters depth of this mixture into a clean test tube. So this mixture, I put it into a clean test tube. Now this is the clean test tube. 1 centimeters. Okay, they're about 1 centimeter. Add sodium hydroxide. So let's add the sodium hydroxide. Here it is, sodium hydroxide. Okay, so I add some. And then what we have here is green precipitate form. And again, it is insoluble in excess. Green precipitate form, insoluble in excess is the answer for the last box. So with this, we complete the experiment for the year 2017.